given the three identical blocks of masses m is equals to 2 kg are drawn by a force F with an acceleration of 0.6 meter per second square on a frictionless surface. Then what is the tension in the string between B and C? And here the options are given. It's a very simple question, so I'll suggest you all to first try this question and then look for the solution. Now here in this type of question, generally we first need to take out the common acceleration of each common acceleration of the whole system, which is equal to the acceleration of each of the block, right? Here suppose we are marking the acceleration which is needed is as t. Now it's given that every block will move with them. It's given that the common acceleration is 0.6 meter per second square, and from the general law we know that it will be the acceleration of block C also. So the only force which is acting on the block C is tension force, which is being generated due to this force F, right? So tension which is applied, which is also a force, will be mass into acceleration, right? So mass of the block is 2 kg, as each block is of 2 kg, and the common acceleration is 0.6, so it's 1.2 Newton, and it's given in option B. So it's a simple one. Thank you so much. So welcome to the second question, which was asked in 2002 JEE mains. This is slightly better question than the first one. Again, I'll suggest you to first try it and then look for the solution. Let's read the question first. A solid sphere, a hollow sphere, and a ring are released from top of an inclined plane frictionless so that they slide down the plane. The maximum acceleration down the plane is, for no rolling, we have to find out that the maximum acceleration will be. So let's visualize the condition. The inclined plane, suppose this is the inclined plane and this is theta, which is making the inclined plane with the ground. As this is frictionless, so mu is 0. Now if the body is placed here for no rolling, because friction is 0, so there is nothing to cause rolling. So if it would have been in a rolling, then it would have been a question of rotational motion, but it's question of it's question of Newton's laws, because no rolling is involved, and so the acceleration will simply be A is equals to G sine theta, right? Now the acceleration for all of the body will be same, because as there is no friction acting, so there is no rolling kinetic energy and anything or like that. So the acceleration, the maximum acceleration down the plane is not depending on the mass or anything on the like moment of inertia or anything. So it will be G sine theta for everybody. So everybody will be reaching with G sine theta, and everybody will almost take the same, will take the same time, because the distance is same, the masses are same. So the answer is option D, right? Thank you. So guys, let's start with the third question. The question reads as two forces are such that the sum of their magnitudes is 18 Newton and their resultant is 12 Newton, which is perpendicular to the smaller force. Then the magnitude of the forces are. With the hope that you all have tried, I'm going for the solution. Suppose one force is x Newton, then other one will be 18 minus x Newton, right? Now suppose these are the two forces, that is x Newton, and this is 18 minus x Newton, right? And the resultant will be this one, as the resultant is perpendicular to one of the forces, and here is given that it is perpendicular to the smaller force. So we can write that resultant, so we can transfer this x Newton to here, right? And from this we can very simply see that this is nothing but a Pythagorean triangle. So we can write 18 minus x whole square is equals to x square, and here the resultant, which is r square. It is here the resultant is given as 12. 18 minus x whole square is equals to x square plus 12 square. Now opening the bracket is 18 square plus x square plus this is minus 36 my x square plus 1 plus 12 square. We get here x square is cancelled, and this is 324, this is 144, it will be 118, and this is minus, this is 36x, right? And x is equals to 5, so this we get 5, so the other one will be 18 minus 5, that is 13 Newton. So the options are, so the first option, that is A, is correct. Thank you. Again, a very simple question of that string, that block pulley system, which is called the Atwood system. Suppose the question reads as, suppose this is the pulley, and the question reads as a light string passing over a smooth light pulley connects two blocks of masses m1 and m2 vertically. If the acceleration of the system is g/8, then the ratio of the masses is. With the hope that you all have tried the question, I am going for the solution. Suppose the two masses are this and this is m1 and this is m2, and supposing that m1 is greater than m2 in mass, so we know that the common acceleration is the net force which is acting is m1g minus m2g by m1 plus m1g minus m2g, and this common acceleration is given as g/8 is equals to m2 minus m1. So m1, this is m1 minus m2, right? m1 plus m2 into g. So m1 minus m2 by m1 plus m2 is equals to 1/8, and 8 of m1 minus 8 of m2 is equals to m1 plus m2, and this is 9, this is 7m1 is equals to 9m2. So m1 by m2 is nothing but 9/7, which is given in option.